Hello everybody, this is Professor Algara and welcome to chapter number 3 in Thermodynamics. This chapter is named as Properties of Pure Substances, and before we start, let's just remember what we've learned in previous videos. We were talking about the first law of thermodynamics. We were also talking about heat, work, energy interactions and things like that. So now it's a good time to start defining the way we define states, how we find intensive and extensive properties, and at the end how we fully define an exercise or how we solve exercises. So a pure substances is the first term that we need to define. And why is that? Because that's what we are studying in the chapter. So a pure substance is defined as a substance that has a fixed chemical composition throughout. A pure substance that does not have to be a single chemical element or compound. A mixture of various chemical elements or compounds also qualifies as pure substances as long as the mixture is homogeneous. For example, air. Air is a mixture of several gases but is considered to be a pure substance. And then we talk about different phases, and everybody probably knows the phases. So we have solid phase, liquid phase, and gas phase. In the solid phase, the molecules are in a solid arranged in a three-dimensional pattern. So basically, they're very organized. You can see the pattern, like the different molecules. Then when we go to the liquid phase, in the liquid phase, the molecular spacing in the liquid phase basically is not much different from the one in the solid phase, except that the molecules are not longer at fixed positions relative to each other, and they can rotate or translate freely. In the liquid phase, the molecular forces are weaker relative to the solids, but still relatively strong compared to gases. The gas phase, on the other hand, everything is very disorganized, and in this state, all the molecules are very just flying around and moving freely with no restrictions at all. What is very important about everything is that we have to define the phase change processes of a pure substance. So everybody's very familiar with liquid, solid, and gases. But in reality, we have different, we have other states that are involved with it. And we're going to start defining each one of them. In the first one is something that is called compressed liquid or subcooled liquid. It's a substance that is not about to vaporize. So basically what's happening in the state number 1, you can consider a piston cylinder device containing liquid water at 20 Celsius and 1 atmosphere pressure. Under these circumstances, the water exists in the liquid phase and it is called compressed liquid, or, like I said, subcooled liquid, meaning that it's not about to vaporize. What's happening here, heat is now transferred to the water until the temperature rises. Let's say, 40, 30 Celsius. As the temperature rises, the liquid water expands slightly, but just slightly and a little bit. And the volume also increases a little bit. So again, super simple. The only thing that is happening, we have a cylinder and piston with water at 1 atm and 20 Celsius. So the heat is being transferred to the water until it reaches close to 40 Celsius per se. All right. So the second one is what we call the state number 2. And that state number 2 is a liquid, saturated liquid, and it's defined as a liquid that is about to vaporize. So what happened here, we have the same pressure atm, but now the temperature has reached 100 Celsius. So what's happening in this state is that the liquid, it's about to vaporize. So in the previous one, we only had liquid, right? And then the heat was coming into the system, and then we are going to start seeing particles of vapor, and that's what happens. So at 1 atm pressure and 100 Celsius, water exists as a liquid that is ready to vaporize. And then we call in the third one, which is saturated liquid vapor mixture. And this one is very important. And why is that? Because in this one, we're going to have a mixture of the different states. So in the first one, we had only liquid, and the second one, we had liquid, but it was about to vaporize. And now that the vaporization started, we're going to have some vapor and some liquid. Okay, what's happening here is the heat keeps coming into my system, and as it comes to the system, the temperature of the water is raising and raising. Okay, so as more heat is transferred, part of the saturated liquid vaporize into what we call the saturated liquid vapor mixture. And then we go to saturated vapor. That's a vapor that is about to condense. So that would be basically the state number 4. As we continue transferring heat, the vaporization process continues until the last drop of liquid is vaporized. Okay, so at this point, the entire cylinder is filled with vapor that is on the borderline of the liquid phase. Any heat loss from this vapor will cause some of the vapor to condense. A vapor that is about to condense is called saturated vapor, and this is called state number 4. Okay, more heat is being added, and as it's being added, the whole liquid has been vaporized, and now we don't have liquid. And then the last one is the one that we call superheated vapor. Once the phase change process is completed, we're back to a single phase region again. This time is vapor. So the first one was liquid. You remember that? So now the heat keeps transferring into my system and the temperature keeps rising. At state number 5, the temperature of the vapor, let's say 300 Celsius or something like that, compared to 20 Celsius that we had at the beginning. So basically what is happening in this stage is the heat keeps coming, the temperature keeps rising, and the volume keeps rising as well, because now the piston is moving upward, changing the volume of the substance. And why is so important that I'm defining all these states? The reason why I'm defining the states is we are now to place the properties into a plot that is called TV or PV diagrams. Diagrams are always a lot easier to visualize when we're treating thermodynamic problems, because in that way we can see how the substance is behaving with the volume and temperature, but also with time. So we were defining 5 states. So 1, 2, 3, 4, and 5. So the first one, compressed liquid, that's a single phase, only liquid is spent over there. So as the temperature was rising from 20 all the way to 100, we reached the second one. The second one is called saturated liquid, and basically at that stage we start having molecules of molecules of vapor, and now everything is vapor, gas, vapor, vapor, liquid, vapor, liquid, vapor, liquid, until it reaches number 3. At stage number 3, it's only vapor what I have. Okay, at stage number 3 we have the mixer. In stage number 3 we have gas, vapor and liquid, until it reaches number 4. At number 4 is when we have only vapor, because everything was vaporizing. So it's simple, okay? You have to see it in a simple way, and let me just try to put it again in something very simple. So at first you have liquid, and then you have mixer, and then you have vapor, and then you have superheated vapor. Okay, and the temperature goes like this, from 20 Celsius to, let's say, 400. Okay, so basically at first we have everything in liquid, and the temperature keeps rising until it reaches, I think it's 100 Celsius. And 100 Celsius we have mixer, that it's probably some percentage vapor and some percentage it's going to be liquid. So in mixer we have some percentage in vapor and some percentage in liquid. Right here we have 100% liquid. Then on vapor we have 100% vapor, and then we have on superheated vapor 100% vapor, but a very high temperature. Okay, so what it's important is a mixer, because liquid, vapor, and superheated vapor, they're super simple to define, but the mixer is what it's kind of tricky, because you need to know how much of your substance is vapor and how much of your substance is liquid. And we are going to develop the equations to do that. But as for now, it's very important that you know that all these states are going to be present at any thermodynamic problem. And that's pretty much everything that we'll be covering for this video. So we just got from 3.1 to 3.3, and the next videos I'm going to show you exactly how we plot everything, the diagram. Thank you very much for listening.